Hi, hello everyone. So today we're going to have a look at a couple of different concepts. So today we're going to start with the most basic thing in trigonometry, which is the radian. So I'm going to draw a circle. Now, center of the circle is right there. The problem with a circle is that we're used to dealing with circle in terms of degrees. And degrees are 360 degrees in one circle, 180 degrees in a semicircle, etc., etc. Now, degrees are fine. Okay. The problem with degrees is there's absolutely no relationship between this number and this circle, apart from somebody 3,500, 4,000 years ago in ancient Babylonia or somewhere just decided we're going to split this up into 360 because 360 is a nice number. We can find loads of fractions in 360. So that's literally it. It's an arbitrary number created by a human a long time ago, and everyone's just stuck with that number. The problem is there's no intrinsic relationship between this circle and this number. I could make this number 400 and I could train everyone in the world to work out of 400 or work out of 100 or work out of 1,000 and it'll be exactly the same. So in order to do maths at a more higher level, we need to come up with some way of representing the divisions in a circle, i.e. the degrees in a circle, using a different measurement, but this time it's a measurement that takes some essence of the circle into it, hence the radian. So let me explain what a radian is and how one works out a radian. Okay, so if we take a full circle, a circle would have a circumference. And our circumference, for want of a better word, is just the length around the edge of the circle. If you divide that length by its diameter, and the diameter is the distance from one side to the other going through the center, you will get the same number every time, and that number is pi. Do not use 3.14, do not use 22/7 because pi is an irrational number. It's pi. Okay, it's a number, it exists, and it's the same no matter how big or small the circle is. It'll always be circumference divided by diameter will always be pi. Okay, now we know that half a diameter is a radius. So this is where I'm going to show you some unusual factors. If I draw a radius, single radius, okay? So actually, before I do that, I'm going to show you, prove that this is true. So let's take a circle with a radius of, let's go with a radius of 3.4. Okay, so this circle, let's call it C. C has a radius of 3.4 centimeters. Now, let's work out its diameter. C has a diameter of, well, double that, 6.8 centimeters. Now, let's get the circumference of this circle. The circumference is equal to 2 pi r. So let's work this out. Okay, so the circumference of this circle is 2 multiplied by pi multiplied by 3.48. Sorry, 3.4. Apologies, there's no 8 there. Okay, so that's 6.8 pi. Now, circumference divided by diameter should be pi. So 6.8 times pi is the circumference divided by the diameter, which is 6.8, is indeed pi. So there's your proof straight away there that that is true. So now that I've done that, so we've gotten that out of the way to proving that that is true. That's how you get pi. Let's have a look at radians. So I'm going to draw me another circle. So imagine, if you will, drawing from the center out to get a radius. Now, here's the really cool bit. Imagine taking this distance and measuring it up along here. Okay? So the same distance from there to there is the distance from there to there. And then imagine drawing. So this distance and this distance are the same, and this distance on the curve is the same. The angle that's made by these two straight lines, if that arc length is equal to the radius, that angle is a radian, 1 radian. Okay? Now, it's not in degrees. You can work it out if you want. It's roughly 57.3 degrees, but do not use it in degrees. It's just 1 radian. And what makes this amazing is that there are 3, it's working it out for you, 0.142857 radians in half a circle. Okay, and more importantly, in other words, there's pi radians in a semicircle, and therefore there's 2 pi radians in a circle. Now, why is it important that? Because radians are built using the circle. It's not someone that made this up. Every circle in the universe, if you get its radius and you work out the arc length as a radius and complete the straight line, that angle in there will be 1 radian no matter what, which means that every circle in the universe has pi radians in a semicircle, in other words 3.14 and a bit, and 2 pi 6.28 and a bit radians in a circle. And that's an intrinsic value that will never ever be untrue. Okay? Now, how does that help you? Well, it allows you to start building complicated things about circles and about angles using radians, which are a lot easier to deal with because you can deal with them. Because when you're dealing with things that have pi tends to be a problem. But if you have loads of things with pi, suddenly you can cancel the pi's out, and it can make things a lot easier. So I'm going to show you a couple of examples of this. Right, so first example, I'm going to convert 2 pi over 5 radians into degrees. And then I'm going to convert 210 degrees into radians, just to show you how quick and easy this is. Okay, so watch how easy this is. So 2 pi radians into degrees. Well, what is 2 pi? 2 pi radians, forget about the 5, 2 pi radians is 360 degrees, isn't it? It's a full circle. So that's just 360 divided by 5, which is 72 degrees. Done. Let's turn 210, okay? So let's think about it. 210 degrees, well, what would 1 degree? Well, wouldn't that just be pi divided by 180? Because pi, we know, is half a semicircle, and we also know half a semicircle is 180 degrees, so they both must be 1 degree. So let's just multiply that by 210, and you get 210 pi over 180, which is 21 pi over 18, which is 7 pi over 6. And there you have it. backwards and frontwards. So easy to do. Okay, now there are a couple of cool things. You'll see these in your log tables, but if I draw my little circle again, and let's say this is the radius, and let's say that's theta, and that's also the radius, well then the length of this arc, I'll try and put it in purple if I can, the length of that arc, even if it's not a radian, the length of that arc will be equal to the radius times theta, which is really cool, so long as that's in radians. Okay, and similarly, if I want to find the area, that's just going to be the area of that arc is just half the radius squared by theta. Now, where is that coming from? You can see where it's coming from. It's pi r squared. That's the circle's area. And this is just the quick way of getting the sector, if you know the theta value in radians. Okay, so that's radians. We will be using them quite a lot. You're better off using them from your log tables. Please use them from your log tables. That's what they're built to be used from.